Hi guys, welcome to Safi Next. In this video, you will learn the different types of vectors. So I'll be talking about types of vectors, and there is a good dictionary about the words, the terminology we use in vectors and specifying vectors and dealing with vector mostly for the graphical representation as well as for algebraic purposes. And I would like to begin from the terminology of uh, graphical representations. And the first thing that I discuss is parallel vectors. So two vectors A and B. Remember, the word parallel vector is in fact a relative terms. We use always several vectors to say one is parallel to the other or not parallel to the other. So this is a comparative word, comparing two vectors with each other. Now, if let's see if this is the representative line of A and this is the representative line of B, then A and B are said to be parallel if they're points in the same direction. And in order to specify the direction, I'll draw a line like this. This is a horizontal line. If this angle theta made by vector A with this horizontal is exactly equal to this angle, then let me call theta sub A and this theta sub B, then the condition for the vector to be parallel is that theta A must always be equal to theta B. That is, if theta A equals to theta B, the angle made by vector A with the horizontal is exactly equal to the angle made by vector B with the horizontal, only then these two vectors are said to be parallel. So we define parallel vectors as two vectors pointing in the same direction are said to be parallel. Now, if you put an additional condition on these two vectors, that is, they are parallel, and alongside that condition, alongside that definition, alongside that characteristic, if the magnitudes of the two vectors is also same, then we define another type of vectors we call equal vectors. That is, vector A and B are said to be equal if they're points in the same direction and alongside they have same magnitude. That is, the length of the line of representative line, I'll write representative line with R, of A is exactly equal to the representative line of B. So two vectors are said to be equal if they point in the same direction and the length of their representative lines is same. So if in order to make them same, B should be of magnitude like this much. Now, that is, this length is exactly equal to this length. When that's the case, we say these two vectors are equal. The next thing that we use in vectors, algebra, vectors, geometry, is anti-parallel vectors. Two vectors, A and B, are said to be anti-parallel if I remove this condition, the length condition that is not needed. This is vector B. However, the direction of B is in this direction. So these two vectors are said to be anti-parallel if they are exactly opposite in direction. That is, if one is making angle theta A, then theta A, and this would be theta B. You see, theta A is in the upward, theta A is above the line, theta B is below the line. Or in other words, say that two vectors are anti-parallel if they are opposite in directions, and two vectors are opposite in direction if they make an angle of pi angle with each other. That is, vector A is in that direction. Then if I put the two with each other, vector B is then in this direction. And this angle is 180 degrees. So two vectors are antiparallel if their points opposite in direction. If the angle between them is 180 degrees, they are then antiparallel vectors. And then there is another vector we call negative. Again, this is a relative term. We always define negative vector with respect to another vector. So two vectors A and B are said to be negative of each other if they are opposite in direction and alongside they are equal in magnitudes. That is, B would be the negative vector of A if it is given by this representative line. It is pointing opposite to direction and the length of B is exactly equal to A. That is, the negative of a vector A is a vector B whose magnitude is the same as that of A, but direction is opposite to A. So then B is called the negative of A, and equally A is called the negative of B. So the negative of vector is in fact a relative term. It always links one vector with another vector. And obviously this is B is antiparallel to A with an additional condition that the magnitude of B is exactly equal to A. So two vectors are said to be the negative of each other, and for algebraic purposes, a negative vector is written with a minus sign. So A equals B, but opposite in direction. So the opposition in direction is represented with negative sign. The negative sign indicates opposition in direction. In vector algebra, keep in mind whether we are doing vector algebra, or we are drawing vectors geometrically, the negative sign is used for opposition in direction between two vectors, or one with respect to other. Then there is another type of vector that we use mostly in vector algebra, vector calculus, and that is unit vector. Remember, this is a very important concept used both in vector algebra, vector geometry, and vector calculus. Unit vector, every vector has a direction, and unit vector is used to specify the direction of a vector. So unit vector is associated with every vector. So if we have a vector A, then obviously this vector has direction. And in order to represent their direction, what we do, we write the magnitude of vector and then multiply that with another vector which we put a hat over it, and this hat specifies that this is a unit vector. So that is, the hat is a standard notation for representing unit vector. So what we say, unit vector is a vector whose magnitude equals 1 and is pointing in the direction of A, or in other words, unit vector represents the direction of vector A. So that's true for every vector. If A is force, we would write force like this: magnitude of force multiplied with a unit vector. Now, we say that unit vector is a vector of magnitude 1. We want to specify this thing. So for that, let me take this one equation. From this, let me write this word here first: A, magnitude of A with unit vector A. If I divide both sides of this equation with magnitude, it would go like this: A divided by its magnitude equals unit vector A. Now, look, we divide a vector by its magnitude, and magnitude is a number times unit. So the unit with this vector and the unit with this vector cancel out, or the unit in numerator cancels with the unit in denominator, leaving unit vector dimensionless. So unit vector is a vector of unit magnitude with no dimension. Remember, this is very important. So unit vector has no dimensions. No dimension means we don't use any unit to measure vector, but the magnitude of this is always equal to 1. This 1 is a number with no unit. So unit vector, now finally let me review. Unit vector is a vector that represents the direction of a vector. It has no dimension, no units, and its magnitude is always equal to 1. And we obtain unit vector for every vector by dividing the vector with its magnitude. We will learn how do we find magnitude of a vector analytically. However, we know graphically this thing is the length of the representative line, and this thing contains length plus direction of the vector. So this thing contains two things: direction and which way the representative line is pointing. That is the information of angle, and also the length, and this contains only length, so length cancel and we are left with dimensionless quantity. Now there is another very important thing that we use vectors along the three directions of coordinate axes. So the unit vector along x-axis is usually represented with I with a head. Along y-axis it is represented with j with a head, and along z-axis it is represented with k with a head. But remember, this representation is not global. This is used usually up to the physics of college level. Later on you will see some authors, some books would use this as x with a unit vector, y with a head, and z with a head. And then in most abstract algebra, this thing is changed to E sub I, where I could be 1, which write E1, could be 2, which we write as E2, could be 3, which we write this as 3. And in a more abstract, there is another diversion from this, that we write this in the form of xi, where I equals 1 is the unit vector along x-axis, I equal 2 is the unit vector along y-axis, I equal 3 is the unit vector along z-axis. And similarly, that pattern is followed for this, that is E1 is the unit vector along x-axis, E2 is the unit vector along y-axis, E3 is the unit vector along z-axis. However, you don't need to worry about the representation. The basic thing is that unit vector is a vector, have unit magnitude, no dimension, and is used to represent the direction of a vector. In the end, thanks for watching.